Hello everybody and welcome to the Highland Space Weather Club 2.0 first video lesson. That's right, I am going to teach you a space weather lesson today. So I hope you guys are all getting started subscribing to the Highland Space Weather Club 2.0 if you are new or if you are the current subscriber for our first channel, the Highland Space Weather Club. So this is the sequel to the Highland Weather Club. This is my other main channel, so if you guys want to be at the Highland Weather Club, I put a video in the link down below in the description, and you can subscribe to the Highland Weather Club so you don't miss out on any of the new videos. But this is different. This is the space weather. So we're going to learn about space weather and what it really means in terms of the weather. So if you want, hit the subscribe button and let's go. So first slide, please. So what is space weather? So you may notice about the weather down at Earth, right? Well, space weather is the same as Earth weather. Earth weather means rain, snow, clouds, sun, hot, cold, any of that. So this time, we are going beyond Earth into space. That is right. We are going to cover almost everything in space and especially in our solar system. So we are going beyond Earth into outer space. So, space weather is the condition in the region of space close to the Earth, especially the presence of electromagnetic radiation and the charged particles emitted by the sun that can affect human activity and technology. So we're learning about the space radiation of the magnetic field over there. And this, if it hits Earth, then it can cause space weather. So that's basically what it is. It can have the huge kind of connections to everything, especially the Earth weather. So we're going to talk about that at the end of this video. So let me get started here. So where does it all start? It all starts with the sun. So you may think the sun is like this. There's the sun right there on the beach, setting of the Pacific Ocean. So that is basically what beach day looks like. Well, you are warned. The sun is this. The little gas giant that is a star, and you can see all these dots and light radiation right here and right here with all these funny colors and the creation of art on the sun. So that's the type of sun we're going to be talking about. And here's the reason why. Because it is the 3 different types on the sun that can happen every once in a while. So first off, we got sunspots. You can see with the black holes on the sun right there. And then we got corona holes. With that thing right there, that's the corona hole. And then last but not least, we got solar flares, which is this star-like radiation right there. This is the burst of radiation. So we're going to get started with sunspots. So what is a sunspot? Sunspots are temporary dark spots that appears on the sun's surface caused by strong magnetic field that enhances convection and reduce surface temperature on the surface of the sun. So you can see here, this is the picture from the satellite GL-16, which lifted in 1718, which lifted into space, and this is the clear picture of it by different technology and tools and stuff combined together. And not only that, but surprisingly, this is the same radiation you will see when the sun rises or sets, or maybe just use your eclipse glasses if you still have one from the last year or the August of 2017 eclipses. If it still works for you, you can still use it, and maybe you might see a few of these. So that's what the sunspot is. So if this is what the sunspot is. So the next thing I'd like to talk to you about is corona holes. It is a dark, cooler, and less dense region in the sun outer atmosphere, the corona, where the magnetic field is open to interplanetary space, allowing the solar wind to escape more rapidly. So you can see there's a corona hole right there, and that is actually the upper part of the sun atmosphere. So if you see the dark spot in the sun atmosphere, which you can see in this type of camera, that is the corona hole, which means that it can release so much radiation, so much solar wind, but it's basically trapped under the sun corona. So when the holes open up, the winds just rush out of the sun and heading out into outer space, sometimes hitting Earth. So that's the corona hole. Now the last but not least, the one that every scientist is counting for, is solar flares. A solar flare is a sudden, intense release of energy from the sun atmosphere, appearing as a bright flash of light and radiation across the electromagnetic spectrum, including X rays and gamma rays. So you can see there's these radiation right here again. So that is the solar flare, what it is. So how do we measure the solar flares? Well, there it is. This is the graph that is available live on spaceweatherpredictioncenter.com, and you can see how to measure it. So we measure it from the order of the alphabet, A, B, and C. So A flare occurs all the time. So this line right there, that is the A flare. Sometimes it even occurred 1,000 times, but you don't get to see it with any other pictogram. Even with the highest solar flare picture on the sun, you may never get to see the A flare, which is a big good thing, because that basically means that there is no stuff headed right towards Earth. When we start talking about B flares and C flares, that's where it gets more interesting. You will start to see those type of flares on the sun, especially headed into the C-class flare. And it can release small radiation into our atmosphere. So that is what B and C flare is. When we get into M flares, the M flare occurs when the solar flare is a bit higher. This is what is really most common, is the M flares, which means the bigger bursts of radiation and more chance to release a significant corona mass ejection, or CME for short, into the atmosphere. So when we basically get into the M flares, or the M flare range, that's where it gets more interesting. They also measure it from R1 to R52 type radiation. So M flare, like we got like a low M flare, which is a R1, and the high M flare, which is the R2, or radioactive, when we have blackouts on the radio or on the local station, especially on the daylight side of the sun, so of the earth. So, and then when we get into the S flare or the R3, that where it get the most excited. The S flare is a type of flare that occurred annals really rarely. So you can see this is the graph right there. This is the late spectrum. This is the corona movement spectrum. So that thing right there, that is the S flare, and they measure these from 0.01 to 9.99 with higher amounts. The further up you go, and a quicker amount of graph. So you can see this is the end like. This is like the end like 1.1, 1.2 in S flare where they're right there. So this is the 1.2 S class flare. And when we get above there, which is a very, very 1 to 2 times per century thing, that is what we call this a R4 to R5 S flares. This is one of the strongest S flare, and if this is Earth direct, it can hit Earth, and it can be dangerous. So we want to avoid it from going uphill. Instead, we want to go down here or in this section. If that graph is in this section, then we're good. So that's good news. Okay, so why is this all happening? This is because of the 11 years solar cycle. So the solar cycle is roughly a 11-year period of fluctuating solar activity, characterized by change in sunspot windows, solar flares, and coronal mass ejection, with a duration from a period of low activity, which is what we call this a solar meridian, to high activity, which is a solar maxilla, and back again. So this is basically due to the magnetic pole flip of the sun, which happens about every 11 years. There is a pole flip. So when the pole is like in the middle of the sun, that is what we call this a solar maxilla. When this at the end of the poles, like what we have here on Earth, this is what we call it the solar meridian. So the pole flip there occurs when the North Pole becomes the South Pole, and the South Pole becomes the North Pole, and so on. So it flips every 11 years. So this is the graph, and they mandel and those type of mandels. So this is from 1900 to 1910. This is solar cycle 14. It goes from 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And we are currently in solar cycle number 25. So it goes, and we also have this going through I think it's 30 something year or cycle 2, when the peak of the solar maxilla or the number of sunspots go up and go down, which is the solar 24 is the meridian part. And now we're starting to rise again with solar cycle 25. So you guys can see the sunspot windows right there. And then you can see this is the graph. So this is the maximum, this is the meridian right there. So you can see all these wet flashes and colors. This is maximum. So that is also something that we watch for every 11 years. Okay, let's learn about something else. This is called a coronal mass ejection, or CME. A coronal mass ejection, or CME for short, is a massive burst of plasma and magnetic field ejected from the sun corona, which means that it can be a solar flare or a plasma explosion of the sun, can push out the corona, and you can see it rapidly goes away from the sun, potentially impact the earth, and cause the geotic storms, auroras, and the question to technology. So this is what the CME is. So you can see the Earth right there, right here. This is the center of the sun, which is where Earth is. So please note, if you can see cold mass adjustment going up from here and here, that is what we call this a cold mass adjustment that is not aiming at Earth. But if this one order to go all around the sun, like a hollow things, that can be towards the Earth. And that depends on if it's like near side or the far side of the sun. If it's like this, if it's a big solar activity, and if it's a near side of the sun, which is in our side, then we will get that, which is pretty dangerous. So this is something that we also are watching for. So this is the CME or coronal mass ingestion right there. And what happens if it hits Earth? Or if we get high solar storm, we get a solar storm. So when it hits Earth, it can combine into higher speeds, higher solar wind. It can connect to higher magnetic field strength and the thing, and that thing too. So here how the magnetic field swing works on Earth. So it hits our magnetic field, and the solar winds kind of go around and go right into the poles, eventually get it into our stratosphere, and this will cause some pretty lights in the sky, all these G-storm or the aurora, like these nova or solar lights across the North Poles, which is the polar lights, and the South Pole, which is called the solar lights. You can see this is measured by the K index. So we got this G-storm. It weighs from 1 to 5, and in the KD index is weight from 1 to 9. So when it hits 5, that is what we call this a G1 storm. If it hits 6, which is right here, this is what we call it a G2 storm. 7, G3, 8, G4, and 9, G5, which is the strongest storm that we really get. And last time we got this type of storm was last May during the big May solar storm of 2024, in case you guys remember that. And that also happens during the Halloween event as well. So that is something that we do need to watch for, as well as the solar plaza and or the CME hits Earth. So that is so this is a big thing that we talk about here in Space Weather Live. So here is the last slide. So how does this connect to our weather? All of it does connect it to our weather. So G-storm plus high solar storm equals stronger storms. So let's get this. So G-storm plus higher solar storm equals stronger storm. It also connects to earthquakes as well. So especially with these corona holes like we just talked about. So all of this can connect to our Earth weather, to us individually too. So we all have to get aware of that, about why we are controlling our sickness and stuff like that, because the space weather is connected to us. So that's probably one of the biggest things you guys all need to know. Also, what all you guys need to know is that if it connects, it has a positive strength and the negative strength. So the positive strength, think about it like a veil. When the positive strength, the strength like positives up, you can see of a math graph of a veil. So let me draw this out. So this is the last thing I want you guys to know about. So if it's positive, this Earth's surface, there's the solar wind. So if the positive, it goes away and it goes away from the Earth. So which goes up and it goes away from the Earth's surface. But when it hits negative right there, even when it's sharply negative, it goes down towards the Earth's surface. So it goes down towards the Earth's surface, and that can be caused by by geological storm by the poles. So this is what space weather really is. So I hope you found this useful. If you want to learn more about this, I will put a Space Weather Prediction Center and the Space Weather Live on the description down below if you guys want to learn more about this. And I will be posting a lot of shorts plus a few videos, last videos in the Highland Weather Club. So please make sure you subscribe to the Highland Space Weather Club 2.0 and the Highland Weather Club. Please make sure you like, comment, and subscribe and turn on post notifications so you don't miss out any new videos. And here and another channel. And I will see you guys in the next update. So for long. Have a great day, and so long from the Space Weather Highland Weather Club 2.0. Bye bye.